Hi guys, welcome to another video of Mathematics 2. In this case, we're going to see this topic, parallel lines cut by a transversal. Okay, just to remind you that this is a video that belongs to a playlist where you can see the full course of Mathematics 2. So you can see that playlist in the description below. Okay, so we have this line that is called R and this line that is R. So it is important to mention that R is parallel to the line S, okay? And there is also a line that is going to cut those two parallel lines, and that line is going to be called T. So if you can see, there are several angles that are formed, the angle 1, 2, 3, 4, 5, 6, 7, and 8, okay? So there are several theorems that are going to tell us that many of those angles are going to be exactly the same, okay? So for example, we have this section over here. These are the interior angles, okay? I repeat, those are the interior angles. So I'm going to erase that color, okay? It was just to mention that. And also these are the exterior angles, these two and these two, okay? Those are the, I repeat, exterior angles, okay? So there are many angles that are going to be the same. So for example, the alternate, I'm going to write it over here, alternate interior are the same. Alternate interior angles are the same. So alternate interior first, we need to see the interior angles. These are the interior angles. And also, we're going to see that, for example, interior angles, they are alternate, so they're going to be at different sides. So I'm going to have this and this. So I repeat, these two are interior, so they are alternate because they are not in the same side. Okay, so angle 3 equals the angle 6. Also, the angle 4 equals the angle 5. Okay, so that it is the theorem of the alternate interior. They are going to be the same. And also, we're going to have exactly the same for the alternate exterior. I'm going to write it, alternate exterior. Okay, so alternate exterior, we have this one and this one. So they are going to be exactly the same. So angle 1 equals angle 8 because they are alternate exterior, and also angle 7 and angle 2. So they are alternate exterior angles. Okay, so I'm going to write it just like that. Okay, but also there is another kind of angles that they are the corresponding angles, and exactly the same. They are going to be they're going to have the same measure. So corresponding angles, we have this one and this one. So angle 1 equals angle 5, and also the angle 2 equals the angle 8. Okay, and also, well, I'm gonna change color, but I don't have enough colors. Okay, so this angle 3 equals the angle 7. Okay, angle 3 equals the angle 7, and also the angle 4 equals the angle 8. So angle 4 equals the angle 8. So those are the theorems, okay? It's kind of necessary that you memorize them, which one of them are alternate interior, which one of them are alternate exterior, and the corresponding angles, okay? But I'm going to show you another way to see which angles are going to be the same. So let's go. Okay, so we have, I draw the figure again, okay? So I have the two parallel lines, the transversal line, and all those 8 angles. So with another color, I'm going to draw a line, okay? So it's going to be just like this, okay? That is the line, okay? It's gonna be kind of a lighting, just like the Harry Potter's car or something like that. So it is important to mention that all the angles that are being touched by this line are gonna be the same. So that means that angle 1 equals angle 4 equals angle 5 and equals angle 8. Okay, so I repeat, all the angles that are touched by this line are going to be exactly the same. And for example, if you watch the previous video, we can say that the angle 1 equals the angle 4 because they are opposite by the vertex. Angle 4 and angle 5, they are the same because they are alternate interior, and angle 5 equals to angle A because they are opposite by the vertex. Also, we can say that the angle 1 equals the angle 8 because they are alternate exterior angles, and angle 4 equals the angle 5 because they are corresponding angles as the same as 1 and 5, okay? And also we have the other side. So I'm gonna draw another line just like this one, and this one, and this one. Okay, so we have the same case. The angle 2 equals the angle 3 equals, that is equal to the angle 6, and this is also equal to the angle 7. Okay, do you see that? 2 equals 3 because they are opposite by the vertex. 3 equals 6, they are alternate interior. 6 equals 7, they are opposite by the vertex. 2 equals 7, they are alternate exterior. 2 equals 6, they are corresponding, and 3 equals 7 because they are corresponding angles. Okay, so this is the theory. So let's go to solve a problem. Okay, so we have this problem over here. We got these two parallel lines, and we have the transversal line. Okay, I forgot to mention that we need to find x and y. And one important thing is that the problem must mention that the lines are parallel. If they are not parallel, this is not going to work. We cannot use those theorems, or we cannot use that theory. Okay, so for example, if I want to draw the line, for example, I can do this. It's gonna be something like this, and something like this, and something like this. So if you see, you're gonna notice that 120 equals this angle over here. Okay, I'm going to erase that line because that is just going to show me which angles are exactly the same. So this angle equals this. Okay, so I'm gonna erase the line and I'm gonna write it. So 2x minus y equals 120. But I'm going to write the reasons over here, okay, because they are alternate interior angles. Okay, interior angles. Now, what about this angle over here? Okay, if I try to use the same procedure of alternate interior angles, so that means that this angle that is here is gonna be the same as this angle that I have there, but I don't know it. I don't know that angle, okay? But I know, for example, that this full angle over here is 180 degrees, okay? But I already have, from that 180 degrees, I already have 120. So that means that this angle over here is 60 degrees. Okay, so that angle is going to be the same as this angle over here because they are alternate interior. So that's what I'm going to write. So x plus 3y equals 60. What is the reason? It is the same reason, okay? They are alternate interior angles. Okay, so now I need to solve x and y. So if you see, I got an equation system. Two equations, two variables. This is the equation 1 and this is the equation number 2. Okay, so there are many methods to solve equations. It doesn't matter which one you use as long as it's correct, the procedure is correct. So you must have the same answer. So what I'm going to do, I'm going to use the addition and subtraction method. So this equation over here, I'm gonna multiply it by 3. Okay, so if I do it, well, I'm going to write the equation again. So it's gonna be 2x times 3 is gonna be 6x minus y, 3 times y is gonna be minus 3y equals 120 times 3. 120 times 3 equals 360. 360 degrees. Okay, so I'm gonna write the equation number 2. I didn't make any modifications to the equation number 2. So it's gonna be the same. X plus 3y equals 60 degrees. Okay, so why did I multiply the equation 1 by 3? So the letter y, the variable y, can be eliminated. So this is going to be canceled with this. So 6x plus x is going to be 7x equals 360 plus 60. It's going to be 420 degrees. Okay, so x equals 420 over 7. So x equals, how much is that over 7? That is 60. Okay, and I'm going to circle that answer. Okay, that is the value of x. How can I find the value of y? Really easy. I'm just going to take that value of x and I'm going to substitute it in any of those two equations that I have. In this case, I'm going to substitute it in the equation number 2. Okay, so I'm going to write equation number 2. So x equals 60, so it's going to be 60 plus 3y equals 60 degrees. 3y, I'm going to move 60, that is at the left, I'm going to move it to the right. So 3y equals 60 minus 60. 3y equals 0. So y equals 0 over 3. So you can see that 0 over 3 equals, equals 0. Y equals 0. And that must be the answer. Now, I don't want you to get confused. X and y are variables, so that means that they can have any value. They could be positive, negative, 0, or even decimal numbers. Okay, so they can have any value. Okay, so if you want to test, for example, that you did a correct, these are the results, you just substitute. For example, let's substitute the value in the first equation. That would be 2 times 60 minus the value of y, that is 0. I must have 120. Okay, and then 60 plus 3 times 0 must be 60. Okay, now that is a way to test your results. And also you can, for example, okay, this was 120 and this was 60. Okay, so that means that this is 60 and this is 120. Okay, so if I add all these, for example, all these 4 angles, the addition is going to be 360 degrees, and I'm pretty sure that it's going to be 60 plus 60 plus 120 plus 120 equals 360 degrees. Now, don't worry if you're not understanding what I'm just saying. It is just to prove my result. Okay, so this was the theory of parallel lines cut by a transversal, and this is one of the examples. And stay tuned because we're going to see more examples about this topic. Okay, so take care, guys. Bye bye.